All right. So it says, given the function rule and domain. So what they mean by function rule, let's see. Okay, this thing on the left is just the function's name, like f of x, g of x, whatever. Over here tells you what the function does. Like you give it a number x and then it multiplies it by 2 and it subtracts 1. They call this the function's rule. Like the rules are you multiply by 2 and subtract 1 or whatever. So we talked about like if they say what's f of 3, that means if I put 3 in for x, if I replace the x value with 3, then I would get 2 times 3 minus 1, and that'd be like 5. That's the same thing as saying when x is 3, the function value is 5. So we could graph that, just like we did yesterday. It's kind of repeated yesterday. So f of x, it just means the f value, which is kind of like the y value, depends on what you put in for the x. F is dependent on x. So that's just a different way of writing it. But you did the same thing we did yesterday, basically. So on number 1 it says f of x equals x minus 4. And it says d equals negative 203. What do you think they mean d equals negative 203? What's d mean, you think?
Domain.
Domain, yeah, it means x value. So all they want you to do is plug those x values in and okay, it does say make a table to represent this, so I guess we'll go ahead and do that. So the x values we're going to use are negative 2, 0, 3. So all you do is plug in negative 2. Negative 2 minus 4 is?
Negative 6.
Negative 6. Plug in 0. 0 minus 4?
Negative 4.
And then plug in 3. 3 minus 4?
Negative 1.
Okay. And we could graph that. We're not going to. If we did graph it, you know what it would look like? It would be a line. Kind of like yesterday's. Most of yesterday's.
It's like the slope.
We're not doing the slope stuff yet. Next chapter problem. Okay, anyway, that's number 1. Number 3. Okay. Looks kind of the same. It says y equals negative 3x for this, and they give us a domain. This time, though, we're supposed to graph it. So this is what your half sheet of graph paper is for. Negative 1, 0, 2. Okay, so we could use the table, or parentheses, I guess I'll use the table. So the x values they want us to use, negative 1, 0, and 2. All right. If we plug in negative 1 for x, get negative 3 times negative 1 is positive 3. If we plug in 0 for x, negative 3 times 0, y would equal 0. And if we plug in 2, negative 3 times 2, negative 6. So we're going to graph those 3 points. Negative 1, 3, 0, 0. Should we connect the dots? No. The reason we're not going to connect the dots is because the domain is limited to just these 3 things. Should look like something like this. Don't use the graph paper, so it should look better than mine. They are in a line. They should be aligned if you do it right. 1, 3 means left 1, up 3. 0, 0 is in the middle. 2, negative 6 means right 2, down 6. So yeah, there's only 4 graphs, 3 through 6. Number 5, h of x equals 2x plus 1. Well, what should we use for our domain?
-2, -1, 0, 1, 2.
Yeah, you can kind of use whatever you want to, but I'm going to make you use these 5 that we did yesterday. Why am I using these 5? Because they're in the middle of the graph. You don't want to plug in a million because that would be hard to graph. You're going to plug in -2. So if I plug in -2, 2 times -2 is -4, plus 1, -3. If I plug in -1, 2 times -1 is -2, plus 1. If I plug in 0, 2 times 0 is 0, plus 1. 2 times 1 plus 1. Do you guys see a pattern here yet?
Yeah.
What's the pattern?
Negatives on top.
Well, yeah. How much are they increasing by? 2. It's because they're multiplying the x value times 2 every time. So the values are increasing by 2. So this one should be 5. So these all should be lines on 3 through 6. They should, if you get them right, they should all be in a row. You don't have to make these marks on your graph paper because that's what the blue lines are for. Okay, -2, -3, -1, -1, 0, 1. Where's 0, 1 at?
Up 0, no, 0.
Right 0, up 1. 1, 3, so that's right 1, up 3. Oops. And 2, 5. I didn't go high enough. Alright. See how those are in a line? Now, I am going to connect the dots and actually go through the dots. Not very good. I can hit them all. Oh. Yeah, close enough. The reason I drew a line on that one is because the domain was unlimited. They did not assign us a domain, so that means we could use anything. So there's actually infinite points, so it's a solid line on that one. And 6. 6 is the same thing. Okay, number 7. I'm not going to write the whole thing down. So it says write a rule for the function. So this is a, some function has these ordered pairs as a solution. And we've got to write a rule for the function. So the answer is going to be like f of x equals something. Okay, the way that you figure out what the function is you look, what are they doing to the x value to turn it into this y value? So how can I get from 2 to 8 and 1 to 4? So what's one way to go from 2 to 8? Okay, you could add 6, but does adding 6 work over here
No.
or over here? No. What's another way to go from 2 to 8? Multiply by 4. Does that work for this one?
Yes.
And this one?
Yes.
Yeah. So they must be multiplying the x values by 4 to get the y values. So it's just equal to 4 times x. Okay. Number 9, -3, -5, -1. Well, I'm writing down the negatives. Usually the positives are less confusing for people, but that's okay. We'll just 2, 0, 5, 3. I skipped the fraction. Fraction will just confuse us probably. Okay, so how can I get from -3 to -5? Might be easier if I go over here to the positives. How can I get from 5 to 3? -2, does that work for this one? Does that work for this one? Yeah. Yeah, -1 minus 2 is -3. So the pattern, the rule is what they call it, must be they're doing the x value minus 2 to get the y value. The pattern is -2. Number 11. Okay, same thing, they just wrote it differently for whatever reason. Let's look at, maybe focus on the evens again. This one's kind of... So, the first column that says x is -5, y is -15, that's basically what that means. It's like -5, -15, -2, -6. What's the pattern here? How do we get from...
Times 3.
Yeah, from there to there, that would be times 3. And that works on this one, as all of them are times 3. So what am I going to write? 3 times x, 3x. Okay, 13 is a tricky one. I gotta just write what they wrote there. 100, -98. 50, -48. 0, 2.
Would it be times -1 plus 2?
Okay, we've got to guess.
Times -1.
2 minus x.
Times
X minus, in parentheses, 2x minus 2. That
Okay,
works for 100.
so,
I'm not sure which one.
Davin, say yours again.
times -1 plus 2.
So x times -1 plus 2. Okay, and Avery, what was yours?
X minus 2.
The other way. So do
-2 minus x, or 2 minus x.
2 minus x. I didn't catch it. What was yours, Jesse?
X minus 2x minus 2. X minus, in parentheses, 2x minus 2.
Like this in parentheses?
No.
That?
There, yeah.
Like that?
Yeah.
Okay. Yes, yes, and pretty close. Actually, no, that one would work. We're kind of going a long way to get to it, though.
It works for 100, I'm not sure it works for 0.
Yeah, it works for 0. So when you minus the 2x, if you minus this stuff, that would just be like plus 2. So what's x minus 2x though? Negative x plus 2. What's another way we could write this one? Negative x plus 2. What's another way we could write this one? Negative x plus 2. So you're all right. Yeah, this is the simplest way. Yeah, because they're almost the same, right? 198. If you make this negative 100, like if you make that negative, then how can you turn it into 98? It's actually a plus 2, because negative 98 is 2 bigger than negative 100. So it's like negative the top number plus 2. But yeah, you guys all three of you had a pretty good answer. You know, the simplest, so they're all good. I think the book put this one. So f of x equals negative x plus 2, but they're all right. Okay, 15, they just put a graph. How can we figure out the graph? Well, let's just figure out some points on that graph, and then maybe we can figure out the pattern for x and how the x and y are related. So what is the coordinates of that leftmost point on number 15?
0.
Negative 2, 0. It's left 2, up 0. So it's negative 2, 0. And then what's this point right here? Negative 1, positive 1, 0, 2. That might be enough to figure out the pattern. Well, I'll do another one. It's 1, 3. You guys, what's the pattern here? They're all going up from the x to the y by 2. Plus 2, plus 2. So the function is just x plus 2. Whoopsie. That one? Yeah. Okay, 17. Well, that one's not a dot, so that's just a solid line. So how could we figure that one out?
Look for where it meets the corners.
Yeah. So what are some points on that line that are easily identifiable?
-3, -1.
Okay, -3, -1. Yeah, do you guys see where the line goes through the graph at -3, -1?
And then 3 and 1.
Yeah, 0, 0. That might not be as helpful to figure out the relationship. And yeah, 3, 1 is another one. That might be the only. Actually, if you look at the very edge, it's like -6, -2. And at the very right edge, it's like +6, 2. I don't know. Do you guys see the pattern? 6
It's
to.
like times 1/3 or something.
Yeah. You could say times 1/3 or divide by 3. So how would you write divide by 3? You can do it like that. Or times 1/3 would look like that. Yeah, those are both good. Okay, I was debating whether I wanted to try 19 and 20. They're kind of difficult. They're getting a little more complicated right there. Well, 23 and 24 are kind of the same thing. Here. Let's let's just say it's to 20. I might make 20 bonus though, because it's a little bit confusing. Okay, so on 19 and 20 are kind of the same idea. So we got 0, 1, 1, 3, 2, 5. Let me write it this way. This might be less confusing. Okay, trying to figure out how I want to explain this. As the x values are increasing by 1, so it's going up 1, 2, 3, how much are the y values increasing by? Okay, what that tells me is that they must be doubling the x values. As the x values go up by 1, the y values are going up twice as fast. However, if you plug the x value in right here, like 0, does that give me 1? Or if I plug in 1, does that give me 3? No. If I plug in 0, it gives me 0. And if I plug in 1, it gives me 2. And if I plug in 2, it gives me 4. So, yeah, I'm falling short of what I want by how much? 1. So this guy needs some help. It's 1 short every time. So how can I make it 1 bigger?
Plus 1.
Plus 1. So there's kind of a 2 parts to it. I wrote it as y equals, if you want to write it in function form, it's just f of x equals. Same difference. The book will jump back and forth between those two things. Like, this is function notation down here. Yeah, we'll say 20 is a bonus. It's kind of, that's tricky.